In the third question, we have cos 2x, cos 4x, cos 6x. Oh, we have more products over here. Right? We have product of three terms. And for solving this, we need one identity which relates cos A, cos B, converts cos A, cos B into the sum or difference. Okay. So for that, I recall that cos A, cos B multiplied by 2 is equal to cos of A plus B plus cos of A minus B. This is what I recall. Right? Using this identity, I can simplify that expression. Using this particular identity, I can simplify that expression, right? And which two cosines should I take? So instead of taking 4x, let's take the two extremes, cos 2x and cos 2x, cos 2x and cos 6x, and see where does that take us. So we have I equals integral of cos 2x cos 6x together into cos 4x dx. Okay. Once you have this, cos 4x will remain as it is, and you can write the remaining as half of cos 2x into cos 6x will convert to cos of a plus b, which is cos of 6x plus 2x is 8x plus cos of a minus b. Now 6x and 2x can be subtracted. This is 4x. Oh, you could have written minus 4x as well. Yes, I could have written minus 4x as well because 2x is written before. So you can take a as 2x, b as 6x. But do you remember that cos of minus x is also equal to cos of x? Right? So it will not make much of a difference because this product can be written, cos 6x can be written before and cos 2x can be written later. We can take a or b interchangeably as well. Yes. And so we need not worry, and this is what we get. Okay, with respect to x, this is integral with respect to x. What next? This half can be brought outside this integral, okay. But still you have a cos 4x into cos 8x plus you have cos 4x into cos 4x, okay. So you have cos 4x into cos 8x plus cos square 4x dx. What do we do in this particular case? Okay, if you observe carefully, cos 4x into cos 8x can again be converted using that result as sum of two cosines. Yes. Moreover, this cos square 4x. Now, in one of the previous questions we saw sin square x can be converted. This power can be reduced by converting into multiple angle, right? And that is what you'll be doing. So 2 cos square x is also equal to 1 plus cos 2x. This is another result, right? So you remember this result with the help of cos 2x can be written as 2 cos square x minus 1. Therefore, 2 cos square x can be written as 1 plus cos 2x, or cos square x can be written as 1 plus cos 2x by 2. And that is something you should be using. Okay, so we can simplify this further. Yes, half is okay, integral is okay. In this bracket, let's convert this into a curly bracket. Cos 4x into cos 8x will convert into half of cos sum of the two, which is 12x. Sum of the two, which is 12x. And the next thing that you need to do is take the difference. Okay. And we'll take the difference. How will we take the difference? Plus cos of a minus b. Oh, 4x minus 8x or 8x minus 4x doesn't make a difference, as we have seen. This will be cos 4x. Okay, this is this particular term simplified. Plus you have this term cos square 4x. That can again be written with the help of that as half times, in the bracket you have 1 plus cos of double this angle, which is 8x. This is what you have, right? So this curly bracket opens the first term, and the second term this curly bracket gets closed. Okay, respect the brackets, right? Don't miss out on the brackets, and if you do that, you will not face much difficulty. So this half and half can be taken out common from these two terms, and we'll have a 1 by 4 outside. Inside the integral we have cos 12x plus cos 4x plus 1 plus cos 8x. Okay, that's the complete expression in the bracket, and this is what we want to integrate now. This is in a form which is integrable. That was the first thing that we wanted, and we have reached this stage where we can integrate, right? Therefore, I is further equal to 1 by 4 is outside, and I can integrate this cos 12x. Now cos 12x will be equal to what? Cos 12x will be simply sin 12x. The integral will be simply sin 12x, but we'll have to divide by that 12, right? So this is sin 12x upon 12. Okay, next let me take this cos 8x, right? These are all in addition. We can take this term next. This will become sin 8x upon 8. The next term will be cos 4x, which will convert to sin 4x upon 4. And this 1 will convert to x. Oh, that's a complete expression. Yes, 1 by 4 is outside, and you'll add a constant term over here. That is my final answer. Yes, at max you can multiply this 1 by 4 inside this bracket, and you will get 48 over here, 32 over here, 16 over here, and x by 4 over here. That is what you can do. You can leave the answer at this stage, or you can write it as sin 12x upon 48 plus sin 8x upon 32 plus sin 4x upon 16 plus x by 4 plus c. That's the required answer for this third question, as you can see over here.